Now let's quickly write the Java code for arranging coins problem that we are discussing using binary searching technique. So here, as part of the first step, what I want to do is, if at all the coins that I am getting is less than or equal to 0, usually we will not be given negative number of coins. Usually the number of coins will always be positive, but it's just that we are getting the value from the user. Let's put that validation in place. If this is the case, I simply want to return 0 itself, because we can arrange all the coins in 0 steps only. Otherwise, if this is not the case, then we need to find what is the last step that we can arrange all the coins till. Okay, so here for that, let me just define start. This will basically represent the starting step we are starting at, and that is nothing but 0. And end, this I am going to start at whatever the coin that we have been given itself. Along with that, let me just add one variable middle. In the beginning it will represent -1. Now let's run a loop while as long as this start is less than or equal to end. What I want to do, let's calculate the middle step first. So middle is nothing but start plus end divided by 2. Once we reach this middle, till this middle step, how many coins we have consumed, that we need to calculate, right? That is nothing but, we know first step will consume 1 coin, second step will consume 2 coins. So till second step, 1 plus 2, 3 coins we have consumed. So third step will consume 3 coins. So till third step, total number of coins we have consumed will be 3 plus 3, 6. Similarly, fourth step will consume 4. So 6 plus 4, 10. So this basically is nothing but sum of the natural numbers till that point of time. So till middle step, how many number of coins we will consume? That will be equal to middle into middle plus 1 divided by 2, which is nothing but formula for sum of the natural numbers. So here, let me just define one variable, total coins consumed is equal to whatever the middle we have into middle plus 1 divided by 2. So this is the total number of coins that will be consumed till that middle step. If at all the coins that we have been given, if it is equal to the total coins that we have consumed till that middle step, so the last step that we can arrange all the coins given will be till that middle step, right? So here we will simply return middle itself. What if the total number of coins we have consumed till middle step is greater than whatever the coins that we have been given? In this case, what we need to do, totally consumed coins till that middle step is greater than the coins that we have given. In that case, the last step that we can arrange coins will be till that whatever the middle step -1, because the total number of coins we have given is so much, but the coins that we need till that middle step is greater, so we don't have that many number of coins. So the last step that we can fill will be till middle -1. So here simply we will update end with whatever the middle that we have calculated -1. If this is not the case, the total number of coins consumed will be less than the coins that we have got, right? That means after filling the middle step, we still have some more coins that are left that we can arrange in the next step. So basically we need to find that last step on the right part. That right part is nothing but start equal to middle plus 1. So here we will update start is equal to middle plus 1. Okay, in this way we basically execute the logic. And here one thing that you need to remember here is, if at all the total number of coins that we have got is equal to the number of coins consumed till that middle step, we would simply return that middle step here itself. But what if we have filled certain number of steps completely, but after that some more coins were left and we have filled that next step to a certain level. So the step that we need to return will be till whatever the previous step that we had, right? That value we will have it inside this end value whatever we are maintaining. So here we will simply return end itself. Okay, so this is the effective implementation of arranging coins using binary searching algorithm. Now let's just test it and validate. So here the coins that I have given is 10, but let's just try to test it with simple numbers so that we can understand the explanation easily. So let's just say the total number of coins that I'm giving is 1. In that case, how many steps we can arrange all the coins in? only one step, because the first step itself will consume the only coin that we have been given. So if I run this now, the output should be 1. That is what we have got on the console. Now let's just say I'm giving 2 coins. So first step will consume 1 coin. To fill the second step we need 2 coins, but we have only 1 coin. So second step we are not able to fill completely. So the last step that we were able to fill successfully is first step only. So the output here should also be 1 only. So that is what we have got. Let's just say if I'm giving 3 coins, first step will consume 1 coin, second step needs 2 coins, and we still have 2 coins. So totally we can fill 2 steps. So if I run this now, 2 is what we have got. Let's just say I am giving 7 coins. So till second step we've consumed 3 coins. We still have 4 coins. To fill the third step we need 3 coins. So we've filled that successfully. And on the fourth step we have only 1 coin, so we filled it. So the last step that we have successfully arranged all the coins is third step. So if I run this now, the output should be 3. Okay, if I pass any negative number, obviously we will never be given negative numbers, but even if at all we be given negative numbers, I am returning 0, right? So that is what we have got. That is the effective way of arranging coins to find what is the last step that we can successfully arrange all the coins that we have got using binary searching technique. Okay, so that's it for this problem. Thanks for watching. I'll see you in the next problem.